Hi, welcome. So we're sitting here at the Architecture Gathering in Munich, and here's Eberhard Wolff, and we're going to talk about microservices. But first, Eberhard, can you tell us a little bit about yourself and the work that you do?
Sure, thanks for having me. So I'm a fellow with InnoQ. InnoQ is a consulting company in Germany and Switzerland, about 130 people. What I do is I mostly do consulting, I do training. I've written a few books about microservices, about continuous delivery, and obviously I'm giving talks at conferences such as this one, so that's what I do.
So it seems microservices are a staple of software architecture and have been for quite a few years now, and everybody knows about the Death Star architecture at Netflix, and so it seems that there is a significant body of experience with microservices. Now, with all the benefits that we expect from microservices, do they actually materialize in actual organizations?
I think so, and I think that's the reason why we even started with microservices, because obviously the pioneers had some challenges that they couldn't solve otherwise. And I think it's interesting to notice that there is actually quite a lot of different benefits that you can get from microservices. So one of the benefits is that you can scale your organization, because microservices are more independent. Each microservice might be implemented in a different technology. Each microservice can be deployed by itself. So if you have a team that is responsible for just one microservice, they can make technical decisions by themselves, and also they can just deploy new features without a lot of coordination with other teams. So that's one of the benefits. The other benefit that I see is if you have a large system, I think there is, or a large deployment unit, I should say, I think there is a certain speed limit concerning how often you can deploy. Because obviously if you have a large system, you have to test it, and that takes a lot of time. You have to deploy it into production, which also takes a lot of time. And if you have small independently deployable microservices, it's easier to deploy more frequently and to deploy faster. And it turns out, as we've seen in the Accelerate book and in the DevOps study, that deploying more frequently has a lot of benefits. So actually people invest more time in working on new features instead of working on bugs. You get faster time to market for new features, and so on and so on. And I would argue, if you want to get all these benefits, then probably at one point you have to use microservices, because otherwise there is this speed limit that depends on your deployment unit size.
So is that a fair way to characterize it, that the boundaries of your microservices should align with the boundaries in your organization?
I think so, and but I think that is rather a statement about modularization in general. So if you have a large system, you want to have modules in that system. Microservices are one way of implementing those modules, and it doesn't make any sense to have people from different teams working on the same module, because, well, the whole reason why you have modules is because they are independent, and teams should probably work on independent parts of the system, because otherwise they have too much coordination. So it's a statement about modularization in general. However, with microservices you get even more independence, because you can have independent technical decisions and independent deployment.
So, but it seems a typical microservice is going to be smaller than the typical deployment unit in a part of the team, in an organization unit, right? Microservice sounds small. Or is that not, should we not really talk about how big they are, but instead talk about organization boundaries?
Well, from the very beginning, it wasn't really clear how large microservices should be. And I think sort of one way of thinking about it is domain-driven design. And domain-driven design says there is a bounded context, and a bounded context has a separate domain model. So maybe if you have a library, there is one domain model for searching for books, and there is another one for lending books. And those are very different, because if you search for a book, you're interested in the author, the title, and these kinds of things. While if you lend a book, it's just about one copy of the book that you have. So, and then you have very separate parts of the domain, bounded contexts, and those are good candidates for microservices. However, of course, they might still be smaller, so microservices might be smaller than a bounded context, because there might be technical reasons to make them even smaller, and that's fine. it's not set in stone how large a microservice should be. Actually, I think that's one of the problems with the term microservice. As you said, it focuses on the size of the unit, and I'm not sure whether that's really the point. To me, the point is more about the independence, and that is why we came up with the term independent systems architecture that gives a few guidelines about how to make sensible microservices.
Okay, yeah, that makes a lot of sense to me. Now it seems though, so I come from a programming languages background, and so when we have different parts of a system, we tend to define interfaces in the programming languages that we use. And I guess with microservices, you typically use network protocols to do that. So it seems that, I mean, in order to get some of the benefits at least, that when you implement a new feature, you're going to have both, you know, a producer of something and a consumer, so you still need to coordinate interfaces between the services that make up your software. And it seems that, so in a programming language, I can have that, you know, when I compile my system or when I link it, it will check that the interfaces align. And with microservice architecture, that seems to happen at the runtime. Does that not cause problems?
Well, it depends, right? And at the end of the day, what you're talking about is sort of interface evolution in microservices systems. And one of the possible ways to handle that is to have just backwards compatible changes. So in that case, there isn't a problem. In other cases, you would need to have some kind of evolution where you would first deploy the system that implements the interface and provides the new functionality, and then you would deploy the system that actually uses the new interface, because that way it's still independent deployment. You do one deployment at a step, you don't do both deployments at the same time. You want to have independent deployment, as I said before. You are right that maybe you lose static type checking on the interface level. You can, but having said that, I mean, the type problems should rather be the obvious ones, so you should notice that as soon as those two microservices actually are deployed and work together, and then you can just fall back to the previous version. So I'm not sure whether there's such a huge risk around that. And the other thing is, I think that's also something that is more relevant nowadays, even though it has been part of domain-driven design. To me, an interface between microservices is also a communication between probably two teams. And I think that's the much larger, let's say, challenge or issue. It's not just about that there is some interface in the software. It's also that if I'm one of the teams and you represent the other teams, if we do that change to the interface, we have to talk to one another, and we have to understand what we are doing on domain level. And I think that's probably the much larger challenge. And as I said, that also has been an issue in domain-driven design since 15 years or so.
So it still worries me a little bit with the testing aspect of that. If you just deploy one and then you deploy the other later, I mean, do you do in a typical microservice system, do you actually do integration testing beforehand? Or do you just have the organizational structure that makes it cheaper to do that in production?
That's a very good question. First of all, I would argue that doing an integration test is actually sort of a problem, because it means that you compromise on the independent deployment. Because if there is an integration part of your, where all the microservices are tested together, that's the point where the deployment pipelines actually have an integration. And that is a problem, because if I deploy my stuff and I'm in the integration stage, it's probably blocked and you can't do integration testing right now. So you really don't want to do that much integration testing. Now the question is, how do you solve that problem? One of the answers, and I would say the very first answer should be, well, we shouldn't have too much integration testing anyway, because we're aiming for very independent parts of the domain. So if you have a lot of integration testing with your microservices, my first question would be, okay, what is your domain model? How do the domain models interact? And are we having a problem there? Then the next, and then there are, let's say, more technical solutions to that. So one of the solutions is if there is such an interface, I can have the microservice test against a stub. So the microservice that calls the other system now can be tested independently from the original system. And the other system that is called, where we can have a consumer-driven contract test that spells out how this system is being used, how that microservice is being used. And then you have instead of an integration test, you have the stub on the one side and the consumer-driven contract test on the other side. And you have the same stuff being tested, however, into different pipelines, and you don't really have an integration test phase. And lastly, if you deploy a microservice, and if you just monitor it in production, and if the old version of the microservice is still running, and your new version isn't changing any data, so it's sort of running blindly in production, there is no risk. So, and monitoring will tell you whether there is a problem. So with microservices, with the quick deployment, with these rather small deployment steps, and with other tricks, you can reduce the risk of deployment, and that is again one way to get rid of integration tests.
So it seems there's a lot of skill associated with successfully building a microservice-based system. So I guess that's the subject of the Flex curriculum, iSAQB, right?
Yes, so the Flex curriculum talks about microservices, and as I've said before, an important part is to do domain-driven design. So we talk about domain-driven design and how we build bounded contexts and relationships between them. Then we talk about how to set technical standards, how to do sort of an implementation guideline, and we also talk about foundations such as container-driven systems, Kubernetes, these kinds of things. In total, this training really gives you an idea about how to build a microservices system, and not just on the technical level, but also concerning how you do it with splitting up the domain into bounded contexts and these kinds of things.
Excellent. Looking forward to Flex training. Thank you very much, Eberhard.
Thank you. Thanks for having me.